The first part of our topic is the computer system operations. It says that the computer system is like most living organisms in our present-day environment. Why? Because like other living organisms, the computer system is composed of many complex parts and each part has its own characteristic and purpose. We must remember that the operating system ensures correct operation of the computer system by interacting and managing hardware resources. So the operating system is the one that keeping the computer system running properly and no interruption occurs. The computer system operation is a modern general purpose computer system consists of one or more CPUs and a number of controllers connected through a system bus that provides access to shared memory. As we can see in this diagram, the CPU is connected through a system bus, so it can transfer commands to the controller, and the controller transfers the data to the hardware or the peripheral device for the execution of command. And then, the buffer storage is the one that temporarily holds the data when it cannot be accumulated by the hardware. In the diagram, the CPU and the controllers can execute concurrently, competing for memory cycles. Because whenever something has to be executed, it has to be executed in your main memory or your RAM. To ensure orderly access to the memory, a memory controller is provided whose function is to synchronize access to the memory. Next is the bootstrap program. It is the startup process in a computer system to gain understanding of another important facet of the computer system and the operating system. So the bootstrap program is the initial program that runs when a computer is powered up or rebooted. Bootstrap program is stored in the ROM or read-only memory, also known as your secondary memory. The bootstrap program must know how to load the operating system and start executing that system. The bootstrap program tasks to locate and load into memory the operating system kernel. For more context, the kernel is the essential center of a computer operating system. It is the core that provides basic services for all other parts of the operating system. It is the main layer between the operating system and hardware, and it helps with process and memory management, file system, device control, and networking.
Lesson 2.3 Structure. Input, output, operation is implemented using the following techniques. Number 1. Program. In this method, the operation will result in input-output instruction, which is a part of a computer program. Each data transfer is initiated by an instruction in the program. Normally, the transfer is from a CPU register to peripheral device or vice versa. Once the data initiated, the CPU start monitoring the interface to see when next transfer can made. The instruction of the program keep close tabs on everything that takes place in the interface unit and the input-output devices. This is the flowchart for program input and output. Number 2. Interrupt-driven input and output. In this method, an interrupt facility and interrupt command is used to inform the device about the start and end of transfer. In the meantime, the CPU executes other program. When the interface determines that the device is ready to data transfer, it generates an interrupt request and sends it to other computer. Number 3. Direct Memory Access or DMA. DMA is a mode of data transfer between the memory and input and output devices. This happens without the involvement of processor, but DMA controller completes this task faster rate and is also effective for transfer the large data. The DMA controller transfers the data in 3 modes: burst mode, cycle stealing mode, and transfer mode. Burst mode. Once the DMA controller gains the charge of the system bus, then it releases the system bus only. After completion of data transfer, then the CPU was wait for the system buses. And the second one, cycle stealing mode. In this mode, the DMA controller forces to the CPU stop its operation and relinquish the control over the bus for a short term to DMA controller. After the transfer every byte, the DMA controller releases the bus and the again request of the system bus. In this way, the DMA controller steals the clock cycle of transferring every byte. And the third one, transfer mode. Here, the DMA controller takes the charge of the system bus only. Of the processor does not require of the system bus.
My name is Arnold Simon Real and I'm from BSCS E2020.
Primary storage. It is a component of the computer that holds data, programs, and instructions that currently in use, and it's located on the motherboard. As a result, mas mabilis ng data pag-read and written to primary storage to fast access the data and instructions. There are 4 types of primary storage: read-only memory, or it's called ROM, random access memory, or it's called RAM, flash memory, cache memory. And meron din 2 main types of primary storage. There are ROM, which is non-volatile, at RAM, which is volatile. Secondary storage. There are 3 main types of secondary or external storage in the computer system. First, solid-state storage device, such as USB memory sticks. Second, optical storage device, such as USB memory and Blu-ray discs. Third, magnetic storage devices, such as hard disk drives. Speed of the device. To know the speed of your device, based sa pagkakalam ko is dahil rin sa ROM and RAM na ito. And capacity of the device, it refers to how much disk space one or more storage devices provides. May measure mo dito to how much data a computer system may contain. Example, yung computer mo is with a 500 gigabytes hard disk has a storage capacity of 500 gigabytes. Cost of the devices. Bawat year may mga bagong devices na nilalabas at mas tumataas yung cost nun dahil na rin sa capacity ng devices. Next, memory hierarchy grouped into nature of locality. So based sa akin nakikita sa bawat group yung mga important sa device like register, cache, main memory. Dahil dyan malaman ang bilis ng devices, and yung mga nakapaloob sa group na yan is like RAM that shows different classification and characteristic of the different storage media. The higher of the device in the hierarchy, the faster is the access time. Yes, kasi kung ano yung pinakamataas na device ay yung mas mabilis to access time. So, response time, the complexity and capacity are related by their performance. Second, yes, mas nagiging mahal siya dahil na rin sa inboard memory niya and outboard memory niya. Number 3, no, dahil mababa na yung capacity nito kaysa sa higher devices na yung performance niya mataas, maganda yung performance. Number 4, yes, it is more accessed by the CPU dahil na rin sa taas ng capacity ng device na yan.
My name is Arnel Simondrial and I'm from BSCS E2020.
There are lists of different protections in hardware computer system. Dual mode operation. So to ensure the proper execution of the operating system, there are two modes of operation. One is user mode and number 2 is kernel mode. Mode bit, it indicates 0 or user 1. As you can see in the diagram and said here that interrupt occurs hardware switches to monitor mode. I/O protection or input-output protection. A user process might disrupt normal operation of the system by issuing the illegal input-output instructions. Memory protection is a way to control memory access rights on a computer. There are registers in memory protection. Base register holds the smallest and limit register limit the range. Well, as you can see in the table, a pair of base and limit registers define the logical address space used to protect the memory. Time interrupts computer after specified to ensure system maintains control. For example, time is ticking and moving to know that operating system or OS is running on a time.